Hello everyone, welcome to my channel. In this video, I'm going to discuss the example for probability. The probability that Azman will come to the office on time is 0.7. So in here, the probabilities that Azman will come on time to the office is 0.7. And the probabilities that Ali will come on time is 0.4. So the probabilities that Ali will come on time is 0.4. Find the probabilities that A, exactly one of them come on time. Probabilities that Azman will come on time, and at the same time, Ali will not come on time. So Ali on time complement. Or the probabilities that Azman not come on time and Ali come on time. So here we have the situation. Since this is a independent situation, so means that probabilities that Azman come on time multiply with probabilities that Ali will not come on time, or probabilities that Azman will not come on time multiply with probabilities that Ali will come on time. So here we have 0.7 multiplied with 0.6 plus 0.3 multiplied with 0.4, and we will have the answer 0.54. B, both of them come on time. So here we have the situation, probabilities that Azman will come on time and Ali will come on time. So here we have the situation, 0.7 multiplied with 0.4. So the answer will be 0.28. C, neither of them come on time. So here we have the situation, probabilities that Azman will not come on time and Ali will not come on time. So here we will have 0.3 multiplied with 0.6. So the answer will be 0.18. Video, I'm going to discuss the example for random variable. X is a random variable with the following probability distribution table. And here we have the table. So question already mentions that X is a random variable. Means that summation for the probability is equals to 1. So here we have 1 over 16 plus with the A plus with 4 over 16 plus with the B plus with the C is equals to 1. So A plus with the B plus with the C is equals to 1 minus 5 over 16. Simplify the situation. A plus B plus with the C is equals to 11 over 16. So here we have the first equation. Next, where A, B, and C are positive constant, if we have the probabilities that X less than 3 is equals to 3 over 4 plus with the probabilities that X greater than 3. So kindly modify the situation. So probabilities that X less than equals to 2 is equals to 3 over 4 plus the probabilities that X greater equals to 4. Refers to the table. The probabilities that X less than equals to 2. So where we will have 1 over 16 plus with the A plus with 4 over 16 is equals to 3 over 4 plus we have probabilities that X greater equals to 4. So which is C. Rearrange the situation. So A minus C is equals to 3 over 4 minus with 5 over 16. Kindly simplify the situation. So A minus C is equals to where we have 12 over 16 minus 5 over 16. And we will have 7 over 16. So here we have the second equation. And we have the probabilities that X less than equals to 1 is equals to 9 over 7 multiplied with the probabilities that X is from 2 to 4. So kindly refers to the table where we have the probability for X less than equals to 1, which is 1 over 16 plus with the A is equals to 9 over 7 multiplied with the probabilities that from 2 to 4, where we will have 1 over 4 plus with the B plus with the C. Kindly cross multiply the 7 and we will have 7 over 16 plus with the 7A is equals to 9 over 4 plus with 9B plus with 9C. Rearrange the situation. So we will have 7 over 16 minus 9 over 4 is equals to negative 7a plus with the 9b plus with the 9c. Simplify the situation. Negative 7a plus with 9b plus with 9c is equals to negative 29 over 16. So here we have the third equation. Shows that a is equals to 1 over 2. Hence, find the value b and c. Refers to the second equation. Kindly express the situation a as a subject. So means that where we have a is equals to 7 over 16 plus with the c. Substitute the equation number 4 into the first and the third equation. And we will have 7 over 16 plus with the c plus with the b plus with the c is equals to 11 over 16. Simplify the situation. So b plus with 2c is equals to 11 minus 7. And we will have 4 over 16. And simplify the situation. B plus 2c is equals to 1 over 4. So here we have the fifth equation. Next, substitute a is equals to 7 over 16 plus c into the third equation. So where we will have negative 7 multiplied with 7 over 16 plus with the c plus with 9b plus with 9c is equals to negative 29 over 16. So we will have negative 49 over 16 minus 7c plus with the 9b plus with the 9c is equals to negative 29 over 16. Simplify the situation. So we will have 9b plus with 2c is equals to 49 over 16 minus with 29 over 16. So 9b plus 2c is equals to 20 over 16, where we will have 5 over 4 as the sixth equation. So now we have the fifth and the sixth equation. 6 minus with the fifth one. So we have b minus 9b minus b, we have 8b. 2c minus 2c, we will have 0. Then we will have 5 over 4 minus with 1 over 4, and we will have 1. So b will be equals to 1 over 8. Next, substitute the b into the fifth equation. So we will have 1 over 8 plus with 2c is equals to 2 over 8. So 2c is equals to 1 over 8. So c will be equals to 1 over 16. Next, substitute the c into the fourth equation. So where we will have a is equals to 7 over 16 plus with 1 over 16. So a will be equals to 8 over 16, which is equals to 1 over 2. And we already shown the situation. So here we have the table with the random variable 0, 1, 2, 3, and 4. Then we have the probability. My suggestion is to equate the denominator so that all the denominator is equals to 16. So in here we have 1 over 2, 1 over 2, and if we multiply with 8, and we will have 8 over 16. By referring to the 2, again, equate the denominator become 16, so we will have 4 over 16. Next, we have x is equals to 3, 1 over 8, which is equals to 2 over 16. So kindly refers to the question B. We have the probabilities for n, and the n is a subset, and n with the element 1, 2, and 4. So it means that probability for n is equals to probability for 1, which is 8 over 16, plus with the probabilities for 2, which is 4 over 16, plus the probability for 4, which is 1 over 16. So the probability for n is equals to 8 plus with the 4, where we have 12, plus with the 1, and we will have 13 over 16. So here we have the question C. State the mode. So kindly refers to the probability, where we have the highest probability is the mode. So in here we have 8 over 16 is the highest probability. So the mode will be x is equals to 1. Next is to find the median. So as we all know, Fm is equals to 0.5, and we are going to determine where is the location for 0.5, which is the median or the m. So kindly refers to the cumulative distribution. So where we will have 1 over 16 followed by 9 over 16, then we have 13 over 16, 15 over 16, and finally we have 1. So where is the location for 0.5? So very obvious, it is located in median. X is equals to 1. I'm going to discuss the example for special probability distribution. Suppose it is known that the probability for recovery from the infection by a type of virus is 0.1, where we have the probability. From a random sample of 15 sample patient, where we have n. So we have the title, X is binomially distributed with n is equals to 15, and the probability 0.1, where we have recovery from the infection. A, the probability is that at most 5 patients will recover. So here we have probabilities that X and 5. At most 5 patients, so means that maximum is equals to 5. So where we have probabilities that X is less than equals to 5. So kindly modify the situation where we have 1 minus probabilities that X greater equals to 6. Refers to the table with the n is equals to 15 and the probability for the success or the p is equals to 0.1. And we have 1 minus 0.0022. And we have probabilities that X is less than equals to 5 will be equals to 0.9978. B, the probabilities that at least 5 patients will recover. So in here, they mention at least 5. So means that minimum 5. So where we will have greater equals to 5. Refers to the table, and we have 0.0127. C, the expected value or the expected number who will recover. Or we can say the mean. So EX is the expected number, or we can say the mean. The formula NP. So means that 15 multiplied with 0.1 and we will have the expected value or the expected number who will recover will be 1.5. D, the variance who will recover. So variance is equals to NPQ. So multiply the situation, 15 multiplied with 0.1 multiplied with 0.9 and we will have the variance is equals to 1.35. Thank you so much for watching this video. If you think the video is useful, kindly consider to like, comment, share and subscribe.